Good day to our research advisor, Sir Adrales and Ma'am Lorzano, and all the students gathered here today. I am Kais Kitana D, and I would like to bid you all a pleasant day. We, Group 8 of Grade 10 Pythagoras, are here to present our proposed study, anthocyanin extract from sweet potato peels or Ipomea batatas as wood dye. Together with my groupmates Julia Gotico, Jherain Pajares, Denmark Hernandez, and Zhien Milliama.
The first chapter presents the problem and its background. This includes the background of the study, objectives, hypothesis, statement of the problem, significance of the study, conceptual framework, and the scope and limitations.
Background of the study. The sweet potato or Ipomea batatas is a dicotyledonous plant. It belongs to the morning glory family Convolvulaceae. It has a starchy but sweet taste. It is very beneficial to those who consume it because it contains cancer-fighting properties such as carotenoids and anthocyanin to help slow down the growth of certain cancer cells. Anthocyanin are water-soluble vacuole pigments. They may look red, purple, blue, or black depending on their pH level.
People nowadays tend to use chemicals in everyday life, which leads to pollution caused by fumes. These fumes are inhaled by humans and possibly animals, and if this worsens over time, human beings and animals will most likely suffer from lung problems. Dioxins, which may occur during the dyeing process, have been found to be able to cause lung and liver cancer and may interfere with the human immune system. Up to 200,000 tons of artificial dyes are lost in sewages during the coloration process, and escape unnecessary wastewater treatment processes and remain in the environment due to their high durability in light, heat, temperature, and more.
Statement of the problem. Is it possible to produce a product from the skin of a sweet potato? Is sweet potato dye an effective wood dye? How much sweet potato peels will the researchers need for the dye to take effect?
Objectives: to find a safer, more environment-friendly alternative to synthetic or artificial dye. To see the effectiveness of a natural wood dye made out of sweet potato peels.
Hypothesis. Alternative hypothesis. Anthocyanin extract from sweet potato, Ipomea batatas, would be an effective wood dye. Null hypothesis. Anthocyanin extract from sweet potato, Ipomea batatas, would not be an effective wood dye.
Significance of the study. Students. The results of the study will provide additional knowledge to students about the products that can be produced from sweet potatoes. Future researchers. The results of the study may be used as a basis by other researchers for their studies. Environmentalists. The results of the study may show environmentalists more ways to be eco-friendly.
Scientists. The result of this study will show scientists the purpose of sweet potato peels even as food waste and give them more ideas for future study. Society. The result of this study will provide more knowledge to the general public and how it is very important to start thinking of the eco-friendly alternative to slowly heal our environment. The environment. The result of this study may help people resort to more eco-friendly alternatives, which may result to the slow healing of the environment.
Scope and limitations. This study focuses on anthocyanin extract from sweet potato, Ipomea batatas, as an effective and more environment-friendly wood dye. Researchers aim to produce a natural dye from anthocyanin extracts originating from sweet potato peels. The researchers will only base the effectivity of the natural dyes on how many days the dyes will last under natural conditions on 3 samples of the same type of wood.
The gathering of materials. First, the anthocyanin extraction. There's boiling, simmering, and grinding. Second, the planning for setup. The dependent variable is wood dye. The independent variable is the effectiveness of anthocyanin, and the control variable are the sweet potatoes and the type of wood.
Moving on to Chapter 3, Research Methodology. This includes the research design, research locale, materials and instrumentation, methods, procedure, and lastly, statistical treatment. Research design. The research design used in this study was experimental research design. It has a hypothesis, a dependent variable, and an independent variable. The current study is about anthocyanin from sweet potato peels or Ipomea batatas as an effective wood dye. Materials and instrumentation. The study made use of 2 cups of sweet potato peels, water, vinegar, salt, strainer, funnel, measuring cups, coffee filter, cloth, a bowl, a blender, and condiment bottles to store the dye. The boards used for testing are of the same type of wood.
Methods. A. Collecting. B. Slicing. C. Blending or extracting of natural dyes. D. Straining. And E. Dyeing.
Procedure. The researchers will collect sweet potato peels, then the researchers will put 2 cups of the peels and 2 cups of the hot water in a blender with a 1:1 ratio and will wait for 2 to 4 minutes. After, the researchers will take a separate bowl with a coffee filter to sieve the mixture and save at least a 450 ml solution and will be left for 2 minutes to cool.
The extract will be equally divided in 3 cups, with 150 milliliters of the solution in each cup. The cups will be labeled A, B, and C. cup A will contain only pure sweet potato peel extract, while cup B and C will have added mordants. Cup B will contain the extract and 1 tablespoon of salt added, while cup C with 1 tablespoon of vinegar. The researchers will then divide the old wood plank into 3 equally cut wooden slabs.
The researchers will use a 1.5-inch paintbrush for each dye. The brush will be soaked thrice for each sample, and the data will be gathered through the use of spectrophotometer.
Statistical treatment. The researchers will use the one-way analysis of variance test for this study, since there is only one independent variable, which is the dye, but will be subjected to 3 different levels. 1. Pure dye, 2. Dye with vinegar as a mordant, and 3. Dye with salt as a mordant, in which F is the variance ratio for the overall test, MST is the mean square of treatment, which can be found through dividing the calculated total sum of squares in DF treatment, over MSE, which is mean square of error, which can be found through dividing the calculated error sum of squares and the DF error.